What is the infinite self-similarity of fractals? Imagine zooming into a pattern and finding the same shape repeating over and over again, no matter how close you get. That's what we call infinite self-similarity in fractals. It means each tiny part of a fractal looks just like the whole shape. This property allows fractals to have endless detail within a limited space. To understand this better, think about a shape that is self-similar. If part of it resembles the entire shape, it's self-similar. Fractals take this idea to the next level by repeating the pattern infinitely many times at smaller and smaller scales. For example, the Sierpinski triangle is made of smaller triangles that look like the whole triangle. Those smaller triangles contain even tinier copies, and this process continues forever. Most fractals are created through a process called iteration. This means applying a simple rule repeatedly. Each step makes smaller copies of the original pattern, keeping the same design. This recursive process is what makes fractals so fascinating and complex. They seem to go on forever, yet they are built from simple rules. Another interesting fact is that fractals do not fit into traditional geometry. They have a fractional or fractal dimension, which measures how detailed they are as you zoom in. This dimension is between 1 and to 4 many natural fractals, like coastlines or clouds. It shows how the complexity increases with scale. In nature, you can see approximate self-similarity in things like trees, mountain ranges, and river networks. These natural patterns look similar at different sizes but are not perfectly identical. Mathematical fractals like the Mandelbrot set or Koch Snowflake display exact infinite self-similarity, which is why they are so useful for studying complex shapes. This idea helps us model natural phenomena more accurately and has practical uses in computer graphics, signal processing, and even biology. For example, digital artists use fractal algorithms to create realistic textures that mimic natural patterns. In summary, the infinite self-similarity of fractals is the property that the pattern repeats endlessly at every scale. This creates infinite detail and complexity, connecting the world of numbers with the patterns we see all around us in nature.